We're going to be doing completing the square. This is kind of the finishing up the lesson we started in class the other day. We're going to complete the square and we're going to tie it back to what we did in the beginning of the unit from lesson 2.1. Let's go. So you have problems like this, where in the beginning of the unit in 2.1, we were writing quadratic equations in vertex form. So we had some coefficient in front of parentheses, and we had x minus some number inside parentheses, and then we squared it, and then we added k. And then we knew right off the bat that our vertex for our parabola was at the point hk. And so I was able to graph it right away and then draw the general shape. Maybe I could make a table and pick a couple points. Okay, we haven't done pattern of change yet, which is something we'll do when we come back together in class. But when I have a quadratic formula in standard form, I can't plainly see what the vertex is, and this is not necessarily an easily factorable, well, this one is, but oh no, it's not. Yeah, this one can't be factored very easy. I could use a quadratic formula, but we're not there yet. So how do we go from this to this? Well, so I'm going to rewrite it. So I have room to work. X squared minus 8x plus 9. If you read the directions, everything says here. So I rewrite the x terms so they're in parentheses. So the next step is going to be y equals x squared minus 8x. And there's a blank there. Plus 9. So here is my perfect square quadratic, but I just removed the constant. Okay, this is a, b, and c. But now we're adding something here. So what I'm going to do is I'm going to complete the square for what's inside the parentheses. And so I'm going to add my middle space there. I'm going to have x squared. B is 8, so half of b. So to complete the square, I need b over 2, and then I square it. So this is going to be 8 over 2. And I square that. That's going to be 4 squared, which is 16. So minus 8x plus 16. But hold on a minute. I just added 16 here. So now I have a different equation. What I need to do is add and subtract it out here. So if I add, I'm adding a blank space here. I'm going to subtract a blank space here. So plus 9 minus 16. And now I have balance. I've done the same thing on the right side, I've done the opposite thing on the right side of the equation. I added 16 and then I immediately took it away. So the value of my entire equation does not change. Then I'm going to simplify. So I get y equals, I can factor this, and here are my, here are my factors. It's x minus 4 squared. And then I do the arithmetic out here. 9 minus 16, that's negative 7. And I am done. This is the same quadratic function, but now it's in vertex form. I have y equals a times x minus h squared plus k. Here a is 1. A is 1 there. A never changed. H is 4. K is negative 7. So it tells me this is my vertex. I'm at 4, negative 7. Down here, I'm opening up. There you go. That's a rough sketch, obviously. When we talk about pattern of change, it'll make graphing these points easier, and we don't have to make a table and go through all that nonsense. I'm going to factor what just happened. So we're going to do these ones a little quicker. So I'm going to rewrite it, change it to function notation, why not? 3x squared plus 12x. I'm going to add a blank space, so on the outside I have to subtract a blank space. Now, there's a common factor here, so I'm going to factor it out. I have 3. I just divided each term by 3. And I don't have to worry about this 7 because it's outside the parentheses. And this blank will just already be factored because now my b went from 12 to 4. And so I'm going to complete the square using this 4. And so I'm not violating any rules. Okay, and let's go complete the square in blue. If b now equals 4, I'm going to take b divided by 2 and square it. That'll give me my completed square. So I have 4 divided by 2 squared equals 2 squared. That's 4. So I'm going to add 4 here and subtract 4 here. I forgot that. And when I write it, I'm running out of room. I have 3, and then the factored form is x plus 2 squared plus 3. So here a equals 3, just like it equaled 3 back there. H is negative 2, k equals 3. So my vertex is negative 2, 3. Axis of symmetry is x equals negative 2. This is opening up, so it has a min at y equals 3. And so I can tell all those points, but I could not tell you that that's what they were just by looking at the standard form. Let's do the next one. Let's keep it y equals negative 2x squared plus 12x. I'm going to put that in parentheses, add a blank, close my parentheses, minus 5, and then subtract a blank. And in this blank will be the same thing. Okay. I'm going to factor out a common factor from inside the parentheses. So I have negative 2 on the outside, and I have x squared minus 6x plus blank minus 5 minus blank. Okay. Now, we are going to do the same thing. B equals negative 6 now. So b over 2 squared, that's going to be negative 6 divided by 2 squared, which is negative 3. So that is negative 3 squared. Now I have 9. That's the number that goes here, plus 9 minus 9. Factor, I get y equals negative 2 times x minus 3 squared minus 5. Let's do the math right now. Negative 5 minus 9 is minus 14. So now I have my vertex is at 3, negative 14. Axis of symmetry is x equals 3. I have a max. Remember, a is less than 0, so it means I have a max. And that is at y equals negative 14. Okay. And it's scaled by 2. And this is important when we do pattern of change. I'll show you how to use this. All right, your practice will be from the book. It's on page 108. It's problems 12, which is your error analysis problems. It's what we did when we were in the classroom and that scavenger hunt. That's an important one. Make sure you do it. 18 through 48 evens. They're also all important. You need the practice. Make sure you do them. I'll post the solutions later this week. Good luck.